We will design a problem using Staad Pro Connect. Okay, the problem is like this. The height, the length, the width of the building all are given, and we will use M20 concrete and Fe415 steel. The live load is 3 km per meter square, and we will assume any other data as per requirement. Okay. Now we will create the job. All of you can see on the screen. We will choose metric unit, then create. Okay. Now this is the screen where we will do our work. As all of you are familiar, it is not needed to explain it again. Okay. Now before that, some minor adjustment in the taskbar. The issue is arising for that. Now you can see this is our problem. Okay. Now see what we are doing step by step. Okay. Now this is the screen. Then we will go to structural wizard. In the structural wizard, we will just select our this is bay frame. Now we will input all our data in that. Okay. And the length, the width, and the number of bays, we will give it 2. Now this is our structure, this is our frame. Now we will click here yes. Now okay. This is our frame, for which we will do analysis, design, and our foundation design also. Now we will give, in the property section, we will define the beam and column sizes. Okay. We will take uniform size, that is 350 mm for both the beam and both that column portion. Okay. Now we will give the dimension for our slab or plate, that is 120 mm. Now for that we will click the thickness portion. We will give that as 0.12. Okay, add, close. Now all our input is given for beam, column as well as for slab. Now we will assign this. Okay, there R1 is for beam and column and R2 is for our slab. So all of you can please follow the steps that are being shown to you through the screen. How to assign the values, for beam, column and slab. Before the slab assigning, first you have to add plate and you have to generate the mesh, then you can assign the value. Okay, now plate adding work is going on for this structure, for this frame, plate 1 and plate 2. Okay, now you can see that is plate 2, this is plate 1. Okay, now assign. All the values are, the dimensions are assigned, as you can see on your screen. Next step, we will go to the geometry and we will generate mesh. Okay, in that generate mesh, you have to select plate mesh, then you have to divide the plate as your as per requirement, whether that may be 4, 10, 5. Okay, it is always better to take even numbers. Next, meshing type, then okay. Now the beam, column and slab or plate dimensions are assigned. Now material is also selected as concrete. Just check it whether concrete is being selected or not, and assign the value, assign concrete to overall frame. Assign to selected beam and assign. Now for support, we will select fixed support and assign. Before assign, go to the view, take front view, select the support portion, then go to the isometric view. In this way all the footings are assigned. Now we will go to our loading portions, load case details. We will give three type of loads, that is wall load, again a floor load, then dead load and live load. The load details, you can see how it is being assigned, how it is input, the values are input, you can see on your screen right now. I think that is self-explanatory how loads are being assigned. Here we have taken dead load, live load, floor load and wall load, but as per your requirement you can take earthquake load also, wind load, snow load, various other types of loads are there. In this case we will take factor at -1.5, that is for dead load, and live load our value is 3 kilonewton per meter square, but we will, considering the factor, we will take that as -4.5. 3 into 1.5, that becomes minus 4.5 kilonewton per meter square, kilonewton per meter. Now load case 3. Here load case 3 we have considered two loads, that is one is floor load and second one is wall load. Now you can see in this sheet how that floor load and wall load are being calculated. If you have any doubt, you can pause the screen and see how it is being calculated. That 0.12 is thickness part, that 25 is the unit weight of concrete, that 1.5 is the design factor. And after calculations, the loads are being input, the input value is given to the load, using the load envelope tab or load case 3 portion. Then range is fixed, then you can select add. If you have any doubt, you can see this sheet and you can know how it is being calculated. Here 2.65 in a wall load 1, that is the total height is 3 meter floor to ceiling, and beam thickness is deducted from that, that is 350 mm, so that becomes 2.65. Wall load 2 is the for the parapet portion, that is 25 into 1 into 0.3 into 1.5. 0.3 is the thickness of the wall, 1 is the 1 meter height, 25 is the unit weight, and 1.5 is the factor. So wall load, floor load and dead load and live load all are considered, the values are entered and assigned, and range are given, that is 3 to 6. Now after the input of all the load values, now we will analyze the load, we will assign the load values. So you can see how all these steps are being done through your screen. So before assigning the load, ensure that in which member you are giving which type of loads are being assigned. So suppose some load is calculated for floor for slab 1 or for plate 1, so ensure that that load is assigned to plate 1 only. Suppose some load is calculated for plate 2 or slab 2, ensure that that load is assigned to that plate only. Okay, similarly the dead load is given to the overall frame, the live load is given to the overall frame, the wall load and the floor load should only be assigned to the constant portion only. Okay, so while assigning the load, that is most important to ensure the correct load is assigned to the correct position or correct beam or column. Okay, now you can see how these are assigned. You can pause the screen, you can see, you can practice it regularly to see how it is being assigned. You can slow it down also. There is nothing to explain it. Okay, this is the assigned load values. Now you can go to analyze, then before analysis go to analysis command. Okay, then run analysis. It is most important to see whether any error or not. Warning does not matter, only there should not be any error. Okay, you can see the analysis result in the post processing tab. Now you can see the result here, the force, the bending moment, the stress, everything is there. Just you need a click at the required portion. Beam stress is there, plate stress is there. Okay, you can see maximum absolute for plate stress, then apply, then okay, then you can see here the stress at the plate portions. Okay, now we will go to design part. In that design part, the important thing is that we should select concrete first, then we should ensure that at the right portion IS456 is selected or not, otherwise we cannot proceed further. Ensure that first we select concrete, then ensure IS456 is selected, then we can go for our define the commands. We will take FCK and FY, then okay, then select, then define. We will select two values FCK and FY, that is 25 and 415 Newton per mm square. Now we add the required values. Okay, required in, that is our design column, design beam. Okay, take off value, then we assign everything. For design beam we have to assign to beam only. For design column we have to assign the column portions only, and for design the plate we have to assign plate portion only. So while assigning we have as I already told you earlier, while assigning we have to ensure that which portion we need design and what we are assigning and which value to which portion, whether that is beam, that is column, or that is slab or plate. We have to be most careful while assigning. Okay, then design command. Okay, now we will select BS8007 for plate design, that is slab design. Okay, so first we have to select the slab and assign. So I will suggest here, as you can see that I am selecting all the slabs here simultaneously, but I will suggest that you should select the slab one by one. First select slab 1, then select slab 2. Select slab 1, then assign it, then you select slab 2 and assign it. Don't do it simultaneously because error may occur and you may miss it. Okay, actually in the drawing as you are seeing on your screen, I face that problem because you all of you can see that I am selecting again and again that both the slabs. I am trying to select both the plate simultaneously, but I am failing. So later what I did is I select slab plate 1 first, then I select plate 2. Okay, all of you can see in the next few minutes what I did. So now I did first plate 2. First what I did is I select plate 2 and then and assign the value. Assign to selected plate. Okay, next what I did is I go to view portion, then I assigned it. Next what I did is I selected the plate 2. Okay, that is show me show. Okay, now that interior part is cannot be selected, so I go to the view and the bottom section view, then assign. Okay, so various views are there: isometric view, top view, front view, bottom view. Okay, so in this way I can assign the required data, then I run it. You can see 0 error. Now you can see the output file here. In the output file, whatever designs results you need, you can see here clearly. You have to select the required portion in the left and you can see the necessary design part at the right. You can see the design of beam and column by simply clicking on it and go to the design concrete design portions. Okay, now we will go to the start foundation. Because in our frame structure 9 footings are there, so we will select all the loads. Okay, include all, then okay, then a new window will open, that is our start foundation. Here you can see 9 footings are there. Okay, now create a job. In that right hand side we have to input our required values as per our codal provision. We have to select IS456 code, Indian design. So as per our problem, as per our numerical problem and given data, we have to select the values, then include all the loads, then we have to select OK. Uh, then our design parameters is set. Then in that design parameter, various sections are there for concrete, reinforcement, cover, soil, footing, okay, then sliding, overturning. After necessary inputs as per our requirement, we can go for a design, okay, otherwise error may occur. So you can see some red lines, that means error has occurred in our footing design, okay. Now we will click the, we can see that so error is due to some spacing issue. Now that part is being corrected, and we will run again run again it, and we can see that every error is being eliminated and result is being shown to us. Now the spacing issue is being corrected. Now we will run the design portion again and see, okay, and the minimum spacing is changed. Now again we will click on the design, save. Now you can see the result here. You can see the final result here, okay. The isolated footings, 9 footings are there, so you can see the result of 9 number of footings, okay, and print it for your record and submission of assignment. Practice it for so that practice it again and again